So I've been thinking about logging. Logging is one of my favorite things in scrap mechanics, just because um, it's challenging. You know, the way that they implement it. It's pretty. You know, it's not easy to build a good logging machine, and you know, if you look, like Con Gaming did a video recently where they went out and did a lot of logging with the hammer, and he says, well, you know, you can make a machine, but it's not necessarily really that much faster than just whacking it with the hammer. And well, that's a little bit of a disappointing attitude, but it's unfortunately it's true that it's hard to make a machine that is really fast. And I want to make something like that, something that can seriously threaten an entire biome worth of trees. What can we do really excessive? And before we can do that, I think we better understand exactly how the game mechanics work with respect to logging. And to that end, I have constructed a few experiments to see how things go. We're going to be testing different kinds of engines and how well they do. We're going to validate a couple of theories about how stuff works. And anyway, a lot of this, it didn't come as all that surprising, and there are a few interesting bits here and there. But let's see how it goes. Now, first off, I want to talk about the setup here, and we have what amounts to a timer here, and it's built because we have bearings run by electric motors. Electric motors move at a very reliable speed. If you compare it with a gas motor, the gas motors take time to spin up and spin down, but electric motors don't. And in fact, if you look on the Scrap Mechanic Wiki, you'll see that folks have taken the time to measure, just exactly how many degrees per second these things run on the various modes. For our case, we're not going to worry too much about it, but I've put these markers down, and you'll see why, because I have a number of ways that we can cue this thing to work, and one is via the sawmill. Now this thing here, this switch here at the bottom, it's an OR gate, and it takes input from all of the switches I have associated with all of the different kinds of motors that we're going to be testing with. And this little pulse limiter circuit over here. And that feeds up into this AND gate, which takes input from the OR gate. And it also takes input from this sensor, which ensures that the log is there. As soon as the log is cut, it gets sucked into this resource collector, and so therefore this thing will cut out. And then the other sensor is this guy, which determines if our saw blade is in place. And so you see, there it is. All the ducks are in a row, and we will turn this on. This timer is set to 1.5 seconds. And it turned this far. Let me put the thing back. And now we'll set the timer here for exactly 1 second. There you go. And it works likewise for 0.5 second, and it goes to this yellow guy. Oops. And this button here is just connected to the motor that turns this bearing, which just spins it back. And I think it should be self-evident that this is really remarkably repeatable setup here from the timer. It always lands pretty close, and so as far as scrap mechanic goes, that's good enough for measuring. So let's take a look at the controller first. Now I'm going to turn it on at this speed setting, sawmill, it never cuts. But at this speed setting and at the fast setting, it cuts. And it took it a little over a second to do the cutting. So, one of the things that people say is, oh yeah, controllers will cut as long as you have a level 5 controller, and that's absolutely proven by this model. Now, I've heard other people say that it doesn't cut as well as the other machines, and let's go ahead and try that out. And see if we believe them. So now I'm going to connect this electric motor. Expect good things from electric motors. And see our timers reset. Wow. I think we can see that this is an electric motor set to max, and it did about the same as the controller. So we're not seeing any special magic from high powers. Let's try a lower speed, which I think that this is too low to cut. And it is too low to cut. Again, it's all about the speed. Same speed as we got with putting it on max. It's just a matter of achieving that that speed, and and then now with the gas engines, they take time to spin up, and to really get a good picture of how a gas engine is going to do the job here. And we're going to start with this the scrap engine on the lowest power. Oh, whoops. Gotta hook it up to the mechanism. And it gets spun up, and because our there we go. Same result. And now I've got a gas engine over here, and I'm going to bother raising or lowering the machine because we're just on the I'm going to put the gas engine on its maximum setting, and might help if we wired it up. Reset. Same result. So, if you've heard people say that you might as well use a controller for cutting timber, well, it looks to be true. But, here, this is scrap mechanic, so we're going to try another engine. There you go. This, you can't trust this. This didn't fire, but that happens. If anything that can spin it will do the job, but we'll see that there's a bit of a twist in the tail here. And then another scrap mechanic thing which I observed is this: that if I the mere act of pushing it into the wood seems to somehow or another cause physics to happen in the scrap mechanics sort of way. Here we'll advance it. There you go. You can't count on that behavior, but it's a thing. Can't explain why it happens, but it does. So while we're at it, let me hook this guy back up to its bearing, and to keep it from doing that. So there's sort of a hitbox here, and you can see here this setting is the minimum that it will cut at. I've experimentally proven that if I back this off to 14 degrees, right here, if I then spin the blade, it won't cut. It's just not close enough. Right, and I turn this on. Oh yeah, I gotta set it up there. Let's connect it. This motor to prove that point. That there, you have to get a certain distance from the thing, and with this setup, this isn't quite in contact, and this is janking into it as far as it'll go, and then some. And you can see it, at least on this log, it's just touching into that black part. And here we're at 15 again. And so you can see we have, I don't know what that is. That's about a quarter of a block of hitbox where it's sufficiently in contact with the log to to make it cut. So if you wanted to make a machine that cuts wood, you'll have to deal with making sure that it gets in that pretty fine range of distances. Now the next question that we want to answer is more better? And so first let's try it in a configuration like this. Now we can set our... Oh, wait a minute. Why does it think it's cutting? Oh, it's because the sky is turned on. Okay. Okay, so now we have two saw blades connected to our electric engine, and let's go ahead for maximum accuracy's sake. Let's go ahead and max it out. And just a little north of half a second. And just to prove it wasn't some sort of a fluke. There. Okay. Half a second. Now, 2 is good. Surely 4 is better, right? Alright, so for this first experiment, you'll notice that I'm actually connecting the wheel. This is difficult. Let me get this out of the way. I want to get this wheel connected not to the bearing. You'll see I welded it right to the other guy. And let's see how we did. We've got our machine reset. That's exactly the same time we got when we had just the two. But if I rearrange this setup a bit, and instead I give the saw blade its own connection to the engine, Now, there you go. Now we're getting a time of roughly a quarter of what we were before, and just to make sure we didn't see something unusual, let's repeat the whole operation. There we go. Again, about a quarter of what the time was before. So, more saw blades matters. Now, here's a thing that I wanted to try. I haven't tested this myself before, but I'm wondering that business where the it's connected. The when it was just straight stacked, it didn't want to work, and I wonder how it was able to make that distinction, and I wonder if we fooled it a bit. So, and for this experiment, I don't know if you can see it very well, but I connected up this controller, and this has no rotation associated with it, to this basically subsidiary blade, and I'm curious to see if the fact that this second blade is spinning, even if it isn't truly doing anything, whether that fools it into thinking that it is part of the system, and it does. So there you go. There is a curious scrap mechanicism that there just has to be a bearing. That two saw blades connected to each other are no more effective than a single saw blade. But if you really want to have a set of saw blades all stacked together, you can do it. You just have to put a bearing in between them, and the bearing doesn't even have to have a motor associated with it, which is, I think that has some possibilities to it. Now, so what I've shown here is that it doesn't really matter what motor you connect. As long as it spins, it's good. If you see sparks, that's it. It's making it happen, which troubles me a little bit to claim, because I've like many of us, I've created mining rigs, and many times I have seen my mining rig generating piles of spark and not breaking any rock. So I think that there's some science left to do here. Okay, so now that we've established what the engines do, I want to show another thing, which is that logs have hit points. And the way I've got the machine set up now, it's just going to be bobbing into the log, and you can see that the sensor that knows it's cutting is now blinking on and off. And when I engage the motor here, you can see every time it goes down, it does a little sparky, and the good grief, I can't drive today, and the timer is ticking away. And the question that we're answering here is do you have to just have blades in contact with a log for a continuous period of time for blades to work, or what happens if you bounce off? And what I think I've demonstrated here is that logs have basically a hit point pool, and that every spark just takes away from that hit point pool, and that shouldn't be much of a surprise, given that we know, for instance, if I wanted to speed this up, all I'd have to do is smack it with the hammer once, and suddenly it would be broke. So, in any case, that's pretty self-evident that basically they have some sort of mechanic built into it where there's hit points, and every tick that the spinning saw blade is in contact with the log, that peels off some of those hit points. Another question that I'm not going to bother demonstrating, but I have tested this, is, I've been using these birch logs. Would it make any difference with hardwood logs, or these ones from the big trees? Does that make any difference? The answer is no. And that shouldn't be a surprise, since we all know that no matter what tree you hit, it takes the same number of hammer swipes to cut it up. And the only difference is that these bigger guys will refuse to be whacked up by the regular survival mode hammer. But in any case, it's just a simple matter of, it takes basically 1 second's worth of spinning blade contact to take a log from its tree state down to its, well, in scrap mechanic they call this the log state, and so there's nothing special about hardwoods or big trees, that they all cut the same. Alright, came up with a couple other things to test while we're at it. One question is simply, can one blade cut multiple logs? And I think we all know what the answer is, but let's find out. Yeah, it can. The next question is, I've always thought, it's kind of wrong that you can cut on any surface of a saw blade. And I'm never really sure, but if there's any one spot that you wouldn't be able to cut on, it would be dead center right here. Alright, so let's see how we do. These sparks are just dry weight sparks, they don't count. Yep, any surface you can cut. So, that's kind of all I can think of to test with this setup. If you can think of more, let me know. I think it gives me what I need to know in order to to build a logging machine, because I think we can see here that with all of these numbers put together, you ought to be able to make a logging machine that will process logs extremely quickly. And the secret is simply more of these guys, more blades in contact with the tree. That's really the long and short of it. So anyway, I look forward to making a machine. Obviously, the more blades you have, the harder it is to get around, but I don't know, I think I got something solid to work from here. Thanks for listening. Bye.